Hi friends, in this video I am going to explain about the polar plot and how to draw the polar plot. Okay, so I already explained in the last videos or previous videos. So whenever we are going to study about the frequency response analysis, so for that purpose we have to substitute the value of S is equal to j omega. So it is mandatory substitute the value of S is equal to j omega, then only it is possible to study about the frequency response analysis concepts. Clear? So here also same thing. So whenever we are going to discuss about the polar plot, actually what is the definition? So what is the definition of polar plot? Just see here. So the locus traced by the tip of the phasor g of j omega as a frequency omega is varied from 0 to infinity is called as the polar plot. Clear? So here it means g of j omega is the or g of s is the given function. Now instead of s we are going to substitute the value of what? J omega. It means, so he given g of s function. So after that we are going to substitute s is equal to j omega and simplify. So after simplifying, so depending upon the variation of omega, so whenever we are going to vary the omega value from 0 to infinity, so definitely we will get some locus, or simply we can say that what we are going to trace the locus. So this is called as the polar plot. So once again see here, the locus traced by the tip of the phasor g of j omega as a frequency omega is varied from 0 to infinity is called as polar plot. Simply we can say that whenever we are going to vary the omega from 0 to infinity, the value of g omega is changes. So depending upon these variation we are going to get one locus. So that locus we are calling as polar plot. Clear? So for that we have to proceed some procedure. So for example, g of s is equal to 1 divided by 1 plus s into 1 plus 2s. So this is the function he given. So for this function we are going to draw the polar plot. Clear? So just take this function. Now we are going to draw the polar plot means definitely we are going to substitute s is equal to j omega. Okay, so we are going to substitute the value of j omega instead of s. Clear? So that's why j of s is equal to 1 by 1 plus s into 1 plus 2s. So instead of s I am substituting the value of j omega. So here j omega and here j omega. So g of j omega is equal to 1 divided by 1 plus j omega into 1 plus 2 j omega. Okay, so after getting this function I am going to rationalize this total function to draw the polar plot. Okay, so already you know what is rationalizing. Clear? So rationalizing means, so denominator, consider the denominator. So if the denominator consisting of positive signs, then we have to consider negative signs. So just see here, denominator term is what? 1 plus j omega into 1 plus 2 j omega. So we have to consider 1 minus j omega into 1 minus 2 j omega. So take this function and multiply and divide with the actual function like this. Okay, so 1 minus j omega into 1 minus 2 j omega into 1 will give this function divided by, so this total function 1 plus j omega into 1 plus 2 j omega into the actual term 1 minus j omega into 1 minus 2 j omega. It means, so instead of this total term or denominator 1 plus j omega 1 plus 2 j omega, we are considering as 1 minus j omega 1 minus 2 j omega, and we are rationalizing with this term. Okay, so that's why denominator and numerator, just see here, so numerator consisting of only 1, so 1 into 1 minus j omega into 1 minus 2 j omega divided by this denominator term into 1 minus j omega into 1 minus 2 j omega. Clear? So finally you will get this. Okay, now after that simplify and separate the real part and imaginary part like this. Okay, so after simplifying this total term, then you will get what? So this is the real part you will get and this is the imaginary part you will get. Okay, so just simplify and separate the real and imaginary terms. So here imaginary terms means the multiplied with j. Okay, so after that you will get the function g of j omega is equal to 1 minus 2 omega square by 1 plus omega square into 1 plus 4 omega square minus j into 3 omega by 1 plus omega square 1 plus 4 omega square. So this is the function we need to consider to draw the polar plot. Clear? So now in this we have the term omega. Now we need to vary this omega term from 0 to infinity, then you will get different values like this. Clear? So with the help of this only we are going to draw the polar plot. Clear? So here, so this is the actual function, this is the actual function. Now in this function just put omega is equal to 0. So put omega is equal to 0, then g of j omega is equal to, so whenever we are going to substitute the value of omega is equal to 1, then finally after simplifying you will get the value of this real term is 1 minus, if you are going to substitute the value of omega is equal to 0 in the imaginary term, then definitely you will get the value of 0. It means when omega is equal to 0, g of j omega total is equal to 1 minus j0. And same like that, omega is equal to infinity, just substitute omega is equal to infinity in this term, again you will get what? G of j omega is equal to minus 0 minus j0. Now with the help of these two only we are going to draw the polar plot. Clear? So this is clear. So with the help of these two terms, just observe here, when omega is equal to 0, real is 1 value and imaginary is 0. It means what? When omega is equal to 0, the curve starts from positive 1 or the positive real axis, magnitude of 1, and it will ends at imaginary 0. And here when omega is equal to 0 condition, the real value is minus 0 and imaginary is minus j0. It means with the help of by the observation of these two terms, we can say that the curve will starts at positive real axis with the magnitude of 1 and ends at the 0. Clear? So this is clear. That's why just see here. So 1 minus j0, when omega is equal to 0, 1 minus j0 is the g of j omega value, and when omega is equal to infinity, minus 0 and minus j0 is the g of j omega value. That's why, so these two values, so it will start at 1. So positive real axis magnitude 1, here 1. That's why I am considering the magnitude of positive real axis 1. So that's why the curve will start, the polar plot will start at this point, and it will end at what? So j0. j0 means this is the imaginary axis and this is the j0 value. That's why curve will start at this point and ends at this point. But definitely this curve will touches the imaginary axis. Definitely this curve will touches the imaginary axis. But we don't know exactly at what value this curve will touches. That's why to calculate the value of omega on the real axis, we have to consider the value real term, that is what? 1 minus 2 omega square divided by 1 plus omega square into 1 plus 4 omega square. This is the value, real value we need to consider and make it is equal to 0. So with the help of this term, definitely you will get the value of omega. Omega is equal to 1 by root 2. Why we are considering only the real part too? This is the question. Okay, so why we are considering the real term only means, with the help of the observation of this term, it will start at the positive real axis and ends at the 0. It means what? Definitely this curve starts in the positive real axis and it ends at the 0, means definitely this curve will touches imaginary. Without touching the imaginary value, it is not going to end at the 0. That's why to calculate this omega value, we need to consider only for 0. For example, this curve will touches real axis, then we need to consider the imaginary term and make it is equal to 0 and calculate the value of omega. Clear? So with the help of observation of this term, so this definitely this polar plot will touches imaginary axis. That's why to calculate this omega value, consider the real term and make it is equal to 0. With the help of that, you will calculate the value, you will get the value of omega is equal to 1 by root 2. That's why, so this curve will starts at this point and this curve will touch us at this imaginary axis at the value of omega is equal to 1 by root 2 here and ends at this point. But what is the magnitude of this? We don't know exactly. That's why to calculate the magnitude of this axis, we need to consider the imaginary term, this total value, imaginary term, and substitute omega is equal to 1 by root 2 instead of omega. So like this, consider minus j 3 omega by 1 plus omega square, 1 plus 4 omega square, when omega is equal to 1 by root 2. Then you will get the value of minus j into root 2 divided by 3. So by simplifying, you will get the value of minus j 0.471. So this is the magnitude of my 0.471. Minus j means negative imaginary axis. That's why minus j into 0.471. So 0.471 is the magnitude of this from 0 to this curve. Clear? So like this we need to draw the polar plot for any function. Clear? So the main thing is just from this total we are going to observe that we are varying the value of omega from 0 to infinity. You are getting these two terms, with the help of these two terms only it is possible to draw the polar plot. That's why the definition of polar plot is the locus traced by the tip of the phasor g of j omega as the frequency omega is varied from 0 to infinity is called as polar plot. So this total polar plot we are drawn just now with the help of the values of these two, and these two values we are getting when we are going to vary the value of omega is equal to 0 to infinity. Clear? So this is the procedure we need to follow whenever we are going to draw the polar plot. Okay, thank you so much.